All right. So chapter 4 review. Number 1. A fair die is to be rolled and a random variable x is to be defined. Is defined to be -1 if the number on the die is even, and the number on the die if the number is odd. Find the density function of x. So density function means basically we're going to make a table for this. So tables x and then probability. So x is defined to be -1 if we roll an even number. So this is if we roll a 2, a 4, or a 6. Okay, but that's not part of my table. Okay, my table is simply this here. And it's the number on the die if the number is odd. So if I roll a 1, then the number is a 1. If I roll a 3, then the number is a 3. If I roll a 5, the number is a 5. So those are my x values. My x values are -1 if I roll an even, and then it's the number on the die if I roll that number as an odd. So it's a 1 if I roll a 1. If it's a 3, I roll a 3. It's 5 if I roll a 5. Now the probability associated for those. Now probability of rolling an even, there are 6 sides of a die, and half of them are even. So there's a 3 in 6 chance that I roll an even, or you can write 1/2. The probability of rolling a 1, well, there's only 1 out of the 6 sides that is a 1. There's only 1 out of 6 sides that's a 3, and there's only a 1 in 6 sides that's a 5. So those are 1 in 6 chance that I roll a 1, a 1 in 6 chance I roll a 3, a 1 in 6 chance I roll a 5. And that is the answer for number 1. Number 2, a student subcommittee has 8 members, 5 females and 3 males. 2 students are selected at random, and a random variable x is defined to be the number of females selected. Find the density function of x. So again, we're making another table, density function, x, and the probability. So x is defined as the number of females selected. So remember, we're choosing 2 students. So if I choose 2 students, I could have 2 males and 0 females. So that would be a 0 for the female section, because remember, it's the number of females selected is my x value. I could have 1 female and 1 male, in which case I'd have 1 female. Or I could have 2 females and 0 males, which would be 2 females. So I can either have 0 females of the 2 people I select. I could have 1 of them female of the 2 people I select, or I could have both of them be female. So 0, 1, and 2 are the numbers of females that could be in my group. So now I need to find the probability. So the first thing I want to do whenever I'm doing one of these is figure out my denominator. Now that was easy in number 1 because I knew in number 1 that there were 6 sides to a die. So my denominator was 6. But here it's a combination problem. It's a little bit more involved. So there are 8 members in total to pick from, and I'm going to be choosing 2 people from that 8. So the combination of 8 choose 2 is my denominator. That is my total number of ways in total. Just like there are 6 sides to a die, the combination of 8 choose 2 is a total combination of ways I can choose 2 people out of 8. I don't know what that number is. I guess we can use the calculator. I do have one, but we could try it out. So math, go over to the probability, and then use combination of 8, choosing 2, and that equals 28. So all of these denominators will be out of 28. So now now I need to fill out the numerators. So the numerators are the more specific events. So 2 males will be my first one, right? So the combination of choosing 2 males. So there are 3 males in total. And in this first scenario, I'm picking 2 of them. So there are 3 males, and I'm picking 2 of them, and that number is equal to 3. So that would be 3 out of 28 for that first one. Now the second one is 1 female and 1 male. So that's a combination. Let's do the females. There are 5 females to choose from, and I'll be selecting 1, times the combination. There are 3 males to choose from, and I'll be selecting 1. So I'm choosing 1 female out of 5. I'm choosing 1 male out of 3. And that's a total of 15 if you put that in the calculator. And now the last one is the combination of 2 females. So 2 females, there are 5 females in total, and I'll be choosing 2 of them. So the combination of 5 choosing 2, which is going to be 10. And just to make sure everything works, all of this should add up to 28 out of 28. So 3 plus 15 plus 10, that is 28 out of the 28. So everything's been accounted for, which is nice to know. And that is our density function there. Number 3, a student has 5 blank CDs and 8 that contain files. Suppose 3 CDs are chosen at random and a random variable x defined to be the number of blank CDs selected. Find the density function of x. So again, we have x and we have the probability. So I'm choosing 3 CDs, and now x is the number of blank CDs. So that I end up picking when I pick 3. I could pick 3 CDs and I could have none of them be blank. So this would have all 3 with files and 0 blank CDs. I could have 1 CD that's blank. That would mean that I have 2 with files and then that 1 that's blank. I could have 2 that are blank, which would mean I had 1 with files and 2 that were blank. Or I could have all 3 that are blank, which means I didn't choose any file CDs and I chose all 3 were blank. So I could choose 3 CDs, and in that I could have none of them be blank. I could have only 1 of those 3 be blank. I could have 2 of those 3 be blank, or I could have 3 of those 3 be blank. So now the probability part. So again, I need a denominator here. So the denominator is our total. So look at how many CDs we have in total. We have 13 CDs in total, and I'm choosing 3 of those CDs. So the combination of 13 choosing 3, that number will be your denominator. I'm going to let you do the math on that. Just like 28 was the last one, I don't know what this one is, but I'll let you guys handle it. And then for the rest of it, the numerators for these, you'll have to find the combinations of those specific scenarios. So for the first one, 3 with files and 0 blank, this would be the combination of how many are there with files? There are 8 with files. So there are 8, and you're choosing 3 of them. And you're not choosing any blank, so you can just leave it at that. For the second part, you're choosing 2 with files and 1 that's blank. So again, there are 8 with files, you're choosing 2 of them. And then there are 5 blank, and you're choosing 1 of them. Okay, and then these continue on as such. So number 4, find the expected value of x. So expected value is simply, it's kind of like the average for this table. It's like finding average in a way. Hold on a second. Okay. So anyway, to find it, you'd have to multiply the value of x with its probability and get that total for each of these, and then add up that total at the end. So -4 times 0.3. I don't know what that would be, but we can check real quick. Would be -1.2. Right? And you just continue doing that for the rest of these. So multiply all those together, get their numbers, and then you'll have 4 of them over here. Add those all up, and you have your expected value. So pretty straightforward if you have a calculator. Number 5 is like the same thing as number 4, but it has a column over here for those products already. This one didn't have that column built in, but it's okay. And you're just going to fill it in. So remember, the value of x times the probability equals that product. So if you already know the product is -2, then you can take, for instance, on this one, -2 divided by 0.2, and that'll help you find out whatever value goes in that first box there. Also, you know that value of x times probability, so -1 times 0.3 will be the value that goes in this box here. Another thing, you can do that in the last one as well to get this box as well. 10 times 0.1 will equal that number. Now the thing here is, how are you going to get this box is the question. Well, what you need to remember is that probability always adds up to 1. So if you have 0.2, 0.3, and 0.1, that right there is a total of 0.6. Well, what's left over has to go in this space here. So 0.4 would have to be that number in that spot, because that would make it all add up to 1. So you have to kind of remember that probability all adds up to 1, and that the value of x times the probability equals the product. You know those things, and you can sort of reverse engineer and fill out the rest of this table. I'm not going to do it for you. I think you guys can manage that. So number 6. Okay, it's a little laggy, but it's all good. A drawer contains 4 nickels, 3 dimes, and 2 quarters. 1 coin is randomly selected from the drawer. What is the expected value of the coin? So the first thing we need to do is make our density function table, and then using that table, we'll find the expected value, because we can't find the expected value unless we have a table, right, with our value of x and our probability. So we're going to have to create that table first, and then go from there to find our expected value. So x is going to be the value of our coins. So I'm choosing 1 coin. So if I pick 1 coin, I could pick a nickel, and a nickel is worth 5 cents. I could pick a dime. A dime is worth 10 cents, or I could pick a quarter. A quarter is worth 25 cents. So x here is the value of my coin that I choose. Now I need to know what the probability is of choosing that coin. Okay, now remember, I'm only choosing 1 coin. So there are 4, 3, 2, that's 9 coins altogether. So 9 different options, 9 different possibilities I can choose here. 9 different coins to select. Now, for them, of those 9, 4 of them are nickels. So 4 out of the 9 are nickels, 3 out of the 9 are dimes, and 2 out of the 9 are quarters. And again, 4, 3, 2, that all adds up to 9 out of 9. So this is my density function for my coins. I could choose a nickel that's worth 5 cents, and there's a 4 in 9 chance that I pick that nickel. I could choose a dime that's 10 cents, and there's a 3 in 9 chance that I choose that dime, or a dime. And quarters are 25 cents, and there's 2 out of a 9 chance of me choosing that quarter. So now if I want to find the expected value, I multiply these all together. So this ends up being 20 over 9. This ends up being 30 over 9. And this ends up being 50 over 9. And you add up all these fractions together, and you end up with, I believe, 100 over 9. And just to simplify that as a decimals, because we are talking about some money here, 100 divided by 9 is 11.11. So roughly 11 cents would be my average here. Just again, expected value is just when you multiply the x with the probability, and then you add these numbers up. So 100 over 9 is fine. You could leave that, but I think 11.11 is probably a more suitable answer in terms of the form it should be written in. Number 7. So the fish problem, the legendary fish problem. An aquarium contains 7 fish, 4 fish that weigh 200 grams each, 2 that weigh 150 grams each, and 1 that weighs 100 grams. 2 fish are selected at random, and a random variable x is defined associating with each outcome the total weight of the 2 fish. Find the density function of x. Find the expected value of x. So we need a density function, so we need x, and we need a probability of that. Now, x is the total weight of my 2 fish. So I could choose, actually, I'm going to move this over a little bit. I could choose 2 fish that weigh 200 grams. And if I did that, I would have a total weight of 400. So that is the 2 200-gram fish right there. I could choose 1 200-gram fish and 1 150-gram fish for a total of 350 gram worth of fish. I could choose a 200-gram fish and a 100-gram fish for 300-gram fish, but I could also do 2 150-gram fish for 300 as well. So there's 2 ways I could get 300 grams of fish. I could choose a 200 and a 100, or I can choose two 150s. Both of those total up to 300 grams. So there's a couple ways I can get 300. If I chose one of the 150s and one of the 100s, then that would be 250 grams total in fish. And I believe those are all the possibilities in total because I can't choose two 100-gram fish. There's only one fish that weighs 100 grams. So I can't choose two of those because there's only one in general. So I can't have like 200 as one of the possibilities because I would have to have two fish that weighed 100 grams, and I don't have two fish that weigh 100 grams because there's only one fish that weighs 100 grams that exists. So that's my X, and those are the ways I got those X. Now I need my probabilities. The first thing I need for probability is my total. So remember, total should be top of your priority list. So there are 7 fish in total to choose from, and I'll be selecting 2 fish. So the combination of 7 choosing 2 is my total, and that value will be the denominator on all of these. Okay, and I'll let you do that number. I'll let you do that math. Now to find the rest of this, you have to do the combinations. So for the first one, the 400-gram one, that's 2 200-gram fish. So that's a combination of, well, there are 4 200-gram fish in total, and you'll be choosing 2 of them. And that's going to be your numerator. That'll be the number that goes here. For the 350, you're choosing 1 200-gram fish. So there are 4 200-gram fish in total, and you're choosing one of them. And you're choosing a 150-gram fish. So there are 2 150-gram fish, and you're choosing one of them. So you're choosing one of the 4 200-gram fish, and you're choosing one of the 2 150-gram fish. And multiply those together, you get that numerator. Now, the third one, you have 2 things to do, and you've got to add them together. So you have the combination of a 200-gram fish, which is 4 choosing 1, multiplied with the combination of a 100-gram fish, which is 1 choosing 1, because there's only one 100-gram fish, and you're choosing it there. Whatever that is, you have to add it with the other possibility, which is catching 2 150-gram fish. So there are 2 of them, and you're choosing both of them. So there's that total as well. So you get those 2 and you add them together. You have your numerator for that one. And then the last one, you have 1 150-gram fish. So there are 2 of those, and you're picking one of them. You're multiplying it with the 1 100-gram fish. So there's 1 100-gram fish, and you're choosing that one fish. So that value will get your numerator there. So all those, you'll have your fractions built in. Now you should double check that we did this right, and they all add up to whatever out of whatever. But you're not done yet. You have to find the expected value as well. So once you've got those fractions, make sure you multiply x with those values and then add those fractions up at the end. And hopefully your answer should be somewhere probably in the low 300 range. I don't know exactly what the number is, but it should, I would think it's somewhere in the low 300 range. Low to mid 300s maybe, I don't know. But that's what I would expect it to be. So number 8, I don't need that much space for number 8. Number 8 should be pretty straightforward. There are 12,350 students at a college, and we're going to be sending them surveys. 34% of those students are going to reply to the survey. So how many students will actually reply to the survey? Well, all you need to do is find out what 34% of 12,350 is. So 12,350 times 0.34, and you'll get your answer. I believe it's 4,199. Number 9. So the rest of this is very straightforward. It's going to go, what happened there? This isn't working, man. This isn't working. Anyway, I'll try to get that to fix in a second. It's just slow. Okay. Number 9. This is just where you just type a lot of this in your calculator. So we're going to find the probability 0 to 1.5. So standard normal means that the mean is 0 and the standard deviation is 1. So whenever you see standard normal, you have to remember these values that go with it, and because we need to use them in the calculator. So remember, all you're going to do is go to second vars and then normal CDF. So we're going to type our lower bound, and for number 9a, our lower bound is 0 and our upper bound is 1.5. So we're going to put 0 for our lower bound and then 1.5 for our upper bound. And mean 0, standard deviation 1 is already there. So I'm going to leave them alone, paste it, and I'm going to get my answer, 0.433. So I'll let you guys work out the rest of those. It's very straightforward. You have your lower bound and your upper bound, lower bound and upper bound, lower bound and upper bound. And all of those have the same mean as 0, standard deviation is 1. All right. I'm going to have to probably close this and open it back up. So give me a second because it's kind of, yeah. Oh, insufficient memory or disk space cannot be, okay. No one cares. Number 10. So number 10, there's in our notes, there's a formula, not really much of a formula, but it does tell us that x minus the mean divided by the standard deviation is kind of how it's a formula in which you would use to transition something back into a standard normal random variable. But all I'm saying that for is because we're going to use the same normal CDF second vars thing in our calculator. We have our lower bound 13, our upper bound 19, but we need to use this because this tells us the mean and standard deviation as long as you remember which one's which. So we're going to go back to our calculator, go to our second vars, go to our normal CDF. Our lower bound was 13, our upper bound was 19. And now you have to remember that x minus the mean means that this here, 15, is the mean divided by the standard deviation, which makes 2.2 the standard deviation. So those are the numbers that I need to just plug in the calculator. So mean is 15, standard deviation is 2.2. And now just let the calculator do the work. You get your answer. Okay. Number 11. So number 11 is asking, in which cases is the normal approximation to x valid? Now, when it's asking that, it's asking for you just to check if it works or not. And the only way to check if it works or not is using these formulas. N times P has to be greater than 5, and N times 1 minus P has to be greater than 5. If that's true for these, for both of these, then you say, yes, it's valid. If it's not true for any one of them, then you say, no, it's not. So simply plug in the N and the P and see if it's bigger than 5. And if it is, yes. If it's not, no. Number 12, a Bernoulli process consists of 160 trials with probability of success 0.25. Use the normal approximation to the binomial to approximate the probability that the number of successes of x satisfies 35 is between 35 and 45. So there's another formula to this when we use Bernoulli for trials here. So the thing is, we know a lower bound and we know an upper bound. So when we go to our calculator, that's going to be very straightforward to plug in our lower bound and upper bound, 35 and 45. But we need to find the standard deviation and the mean. So when we're talking about Bernoulli, our standard deviation and our mean come from N and P. So the mean is N times P. So in this case, it'll be 160, because N is the number of trials, times 0.25. That will be our mean. So whatever that number is, which I think is like 40. Also, I got to end this video soon because this is not working. That's my mean, and my standard deviation, because it keeps automatically erasing. I don't know what's going on there. My standard deviation is the formula NP1 minus P. Well, the square root of that. So plug in the N, which is 160, plug in the P, which is 0.25, and you'll have your standard deviation, and you plug those numbers back into this calculator and let the calculator do the work. But remember, the mean is N times P. Standard deviation is the square root of N times P times 1 minus P. You're going to do that same exact thing for A, number 13, to find the mean standard deviation. The struggle is real. And B will give you your lower and upper bound as well. I'm going to end this video here. If you're stuck on the last one, just let me know. I think, for the most part, I think the last few problems use those formulas. So you should be able to carry it on yourself. But yeah, I'll see if I can't do chapter 5. But I'm going to leave it there. I'll see you guys in the next one. Bye.